welcome to the session on Introduction to Analytics in Business. We start with some basic terminologies today. We start with data. We develop an understanding of what is data, what is information, and what is knowledge. How exactly does it contribute to this entire realm of data analytics? Let's get started with data. So what do you think is data? Raw facts, figures, that really does not convey any meaning. You can see it here that they are the most elementary description of things, activities. For example, if I have this class of 20 students, I were just to record their marks, just put them down in figures, that doesn't essentially convey any meaning. That's exactly what data is all about. And that is why the reason it is often referred to as raw facts and figures. And therefore, for an organization, for an individual, for data to make meaning, there has to be some kind of processing. It has to be contextualized, it has to be calculated, it has to be condensed, and it has to be categorized. And when you deal with data in these aspects, it becomes what is referred to as information. Data with meaning. So remember the same example of the marks that I had taken earlier? Marks of 20 students in my class. I were to calculate the total and I divide it by the total number of students in the class. I get the average. Now, if I were to ask the question, what is the average marks of this class? I have an answer there. And it is conveying a certain information to me. Look at how meaning has been added on to those raw facts and figures, and it gives you what is referred to as information. And when organizations begin to act on this information, they begin to glean out certain aspects, apply the contextualization there, and begin to make meaning out of this, begin to act on this information, then we have knowledge. Knowledge is important for organizations. And essentially, knowledge can be of two kinds. One, it could be the tacit knowledge, which is there in the minds of the people in the organization. And the other, it could be the explicit knowledge, like what I'm showing you here on these slides. Written, codified, you can read, and you can take whatever is needed. Remember, it is these three blocks which will form the basic building blocks of your entire data analytics understanding. There could be two perspectives to this whole concept of data. One, you could look at it from a business perspective. You could be in the marketing functional area, you could be in the sales, you could be in the finance, you could be in the HR, and you would want to trace back to the sources of your information and data to find where all this came from. You're more bothered about the origin, the quality, all of these kinds related to data. That's the business perspective. On the other hand, the technical perspective will deal with the storage of data, how the data is collected, how it is stored, what are some of the important privacy and compliance issues with the data. All this will have to be covered as from the technical perspective. And for any organization to be successful in dealing with their data, the business perspective and the technical perspective has to be closely aligned. Check it out in your own organizations, how the business perspective works, how the technical perspective works, how together they deal with the data that is flowing into your organizations. Thank you, and I hope you've had a good introduction to what we are going to talk about further. Thank you. Welcome to the session. We are going to be looking at the types of data. How can data be classified? There are several ways of classifying data, and this is important to help you in order to leverage the use of data in your organizational activities, primarily in your decision making. Which data to use, what technology what mechanism can be used in order to manipulate the data. For all of this, the classification of data is necessary. So let's just look at some of the very common classification of data that is encountered. One of the most popular ways by which you can classify data is make it either as qualitative data and quantitative data. You can see it here, various examples that are being given as qualitative data and quantitative data. Let's take a quick example, for instance. If Domino's Pizza finds out that their pizza is not selling and they were to call a few of their customers, potential customers, as well as customers who've come to their shop, and ask them, why is it that, or what is it that you did not really like about our pizza? Or probably they ask, what is it that you like about our pizza? And they talk to them. And the customers are likely to say, well, I love the fact that you are able to deliver your pizza in 30 minutes time. Or I love the fact that your pizza has got so many flavors, but I hate the fact that your cheese is really chewy and sticky. Domino's Pizza can, over a period of time, collect such information that comes in, such data that comes in, and they keep that pool. This is basically qualitative data. Or maybe I'm going to observe the front office assistant at work. I want to see what is the kind of time that the person spends standing at work, sitting at work, how many times the person has to greet the customers, and so on and so on. I'm just taking down certain notes. I'm just taking down certain observations, and these become my qualitative data. On the other hand, quantitative data deals with numbers. For example, I'm collecting the age of people and I'm calculating the average age of my respondents. I'm dealing with numbers, and that numerical data is what is referred to as quantitative data. Now remember, quantitative data itself can be classified into two important categories. You're able to see it here. One is the discrete data and the other is the continuous data. What do you mean by discrete data? If I were to count the number of fingers on my hand, I have 1, 2, 3, 4, and 5 on my left hand. I have I've used whole numbers, I've used integers to do the calculation. This is basically the discrete data, where you are able to discretely specify the number of observations that you are dealing with. At other times, probably when I'm weighing myself on a weighing scale, my weight can go into finer measures, or probably if I'm measuring the height of my child, I can measure it either in meters or make it more finer in centimeters, millimeters, decimeters over a continuous range. This kind of numerical data is referred to as continuous data. 1.1, 1.12, 1.123 is all example of continuous data. Whereas counting the number of chairs in this room, counting the number of students sitting here are all examples of discrete data, a very primary way to classify data. Another way by which you can look at data is to look in terms of the time dimension. So remember, here we are looking at time as a basis of classification. On the basis of time, data can be classified into cross-sectional data as well as time series data. Now, I want you to look at this particular table on the slide. It shows the sales across 4 states in United States of America. And 4 years have been listed: 2016, 2017, 18, and 19. Imagine I collected my data in 2016 and I collected it across California, Georgia, Kansas, and Nebraska. And I collected it at the same point of time. This is what is referred to as cross-sectional data. So data that is being collected at one point of time is what is referred to as cross-sectional data. Now, I could have continued this collection of data as has been shown here in the slide in 2016, in 2017, 2018, and then 2019. This is what qualifies as longitudinal data. So basically, it's a time series kind of data that we are dealing with. We are dealing with data that has been collected over a period of time. It's just like taking a wedding anniversary photo every year. Year after year, the same couple is being photographed just to understand how things change. And this is a great example of longitudinal data. These are some of the important classifications of data. Thank you for listening, and we look at more types of data later. Thank you. Welcome to this session on types of data. What are the different ways in which data can be classified, especially when you're looking at huge amounts of data that are typical of organizations in today's times? A very important way of classifying data will be structured data, unstructured data, and semi-structured data. Let's look at what exactly this means. Structured data includes your data that can be structured into tables. For instance, if you were to keep a record of all the students in this class, I would give them a student ID, I would give them a student name, a date of birth, address, contact number. Let's assume that there are these 5 important data points that I'm going to capture for each student in this class. I would structure them into tables with neat rows and columns. A clear example of structured data. And for a long time, organizations dealt with this kind of data. And they were stored in what were called as databases, relational databases, and the such. We had technologies which could deal with this kind of data. But with the growth in smart devices, we encountered certain other kinds of data. For instance, look at something like Facebook. What does Facebook encounter every day? They take in a whole lot of posts, they take in a whole lot of photographs, videos like what you and I post on Facebook, and this has to be stored in their servers wherever they are doing the data storage. So they essentially can't store all this using just tables, rows, and columns. What they are dealing with here is what is referred to as unstructured data. Unstructured data is very difficult to organize, it is difficult to search, it is difficult to retrieve in the traditional manner in which structured data was often dealt with. And therefore, we need advanced technologies, we need important mechanisms to deal with what is referred to as unstructured data. In between these two, if I were to draw a continuum, on one side you have the structured data, and the other extreme you have the unstructured data. Somewhere in between, you will have what is referred to as a semi-structured data. Think of an email message, for instance. When you go onto your Gmail and you are planning to send an email to your friend or your acquaintance or your boss in the organization, one of the first things that you will encounter is whom are you sending to? So the to, the sender, the subject, and then of course you could be putting an image within your email content. You could be writing text. These are all examples of semi-structured. So there is a certain bit of structure, but there is also some unstructured data that is coming in. Imagine a .csv file, XML. These are all examples of semi-structured data. And much like unstructured data, semi-structured data also requires specific technologies that can be used to manipulate, to work on this kind of data. There is no row, there is no column structure here. And therefore, these technologies is what organizations will have to use in order to leverage maximum benefit out of the data that they are encountering. So, another way of looking at data would be to, especially when you're dealing with a lot of statistical purposes, you can divide the data into four important types. One would be the nominal data, the other would be ordinal, the other would be interval, and the fourth would be ratio data. Now, what exactly is this? Nominal data. Let's start with the simplest and the basic. For instance, if you're doing a questionnaire survey, and if you were to ask the respondents about their gender or about their marital status, they would probably, and you're giving them two options of gender, you're giving them male and you're giving them the female option, they tick one, and then you were to collect all this, what would you typically do with that kind of data? Or you even look at, for instance, if you were to take the earlier example of the student database, just look at the student ID. What is it? It's just a label. And this is what is referred to as a nominal data. At other times, you can also call it categorical data. For instance, in the gender purpose, if we were to survey 100 respondents and categorize into either the male category and the female category, that is your categorical data. You can't do much arithmetic there. All you can do is to classify them into two separate categories. That's your nominal data. The second one is what is referred to as ordinal data. Ordinal data, for instance, there is an order that you are giving to the data. So the first day of the week, the second day of the week, or the first person, the person who came first in the class on the basis of some score, the person who came second, the person who came third. Or maybe I'm asking you a question, what is your preference for shopping? Is it the Lulu hypermarket? Is it hypermarket 2? Is it hypermarket 3? So you might want to rank them and say the first, the second, and the third preference. These are all examples of ordinal data. The next, slightly more advanced level is what we refer to as interval data. Interval data is what you typically find on your temperature scales. You will have regular intervals between the data points. So you have 1 degree, you have 2 degree, you have 3 degree, and so on. And finally, you have the ratio data. Ratio data is the most advanced in the level of data. You can do a whole lot of arithmetical operations, which is not possible with the earlier classification of nominal, ordinal, or interval data. Why? Because if you look at interval data, it typically lacks a true zero. What do you mean by a true zero? For instance, let us go back to our temperature scale. Look at 0 degrees centigrade. What is 0 degrees centigrade? Does it mean that there is no temperature at that point? No, that's not what it means. It means at 0 degrees centigrade, water will turn into ice. So 0 does not convey the lack of something. 0 does not mean that there is not something. That is what is a problem with interval data. There is no true zero. That true zero can be found in your ratio data. So for instance, what is my bank balance? 0 means there is no money in my account. That means I am able to use the ratio data because they are true numbers, and I can divide, I can multiply, I can do a whole range of arithmetic and statistical operations on this set of data. And this makes it very, very valuable. So we've seen some different ways in which data can be classified, either as structured, semi-structured, unstructured, or on the basis of the complexity, on the basis of the arithmetical operations that can be done into nominal, ordinal, interval, and ratio data. Here's an example. For instance, you're able to find this table and you can easily look at what are the different categorical data, what are the different ratio data, what are the different interval data that is available. So this is a purchasing database. And if you look at, for instance, if you look at the cost If you look at the price that is there or the order quantity, these are all examples of ratio data. If you look at the item number, that's just a label and you can call it a nominal kind of data. So, why do you really need to know this classification of data? Because only if you know what is the kind of data you are dealing with, can you use appropriate tools for your data analysis. So more about how to go about this later. Thank you.